One thing that I've noticed during this time of quarantine is the creativity and the resourcefulness of people. We are going to look at a problem scenario today that involves this question. What would you do if you had to cut your grass without a lawnmower? What would you do if your lawnmower was broken down and you didn't have access to a lawnmower? How would you cut your grass? And today we're going to look at how Bill, and the problem that we're going to look at, how Bill comes up with a solution to this problem. Hey, welcome to another lesson today, another geometry lesson. I'm Justin Patterson. I am a geometry teacher at Baker High School. And if you recall from last week, we looked at the arc length of a circle. Now, arc length was the portion of the circumference of a circle. And today, we're going to look at the area of a sector of a circle. Now, we're going to, on the front end, discuss the differences of that, but let's get back to our problem scenario here. What is Bill going to use to cut his grass? Bill is actually going to use a pumpkin, a goat named Pumpkin. Let me introduce you to a goat named Pumpkin. I'm going to play a short video. This is Pumpkin. Pumpkin is attached to a 50-foot rope. So what Bill has done is Bill has attached Pumpkin to a 50-foot rope in different places in his backyard. And Pumpkin is going to over time, and goats are sometimes slow eaters, and they're known to wander from time to time, so it's good that we have a rope attached to him. But Pumpkin is going to, this first piece of the problem is going to rotate around and revolve himself around this tree. Now, I want us to think about this for a second. I want you to imagine that this marker is Pumpkin, and that where my finger is a point on the circle, or the center of that circle. And if Pumpkin were to walk all the way around that tree that I just showed you, what shape would be formed as Pumpkin walks around that tree? And we can see that that shape is a circle. Now, from last week we looked at the arc length of a circle. Now, for that arc length, we were looking at a portion of the circumference of a circle. Now, this week, we're going to be looking at area. Now, area is the amount of space on the inside. So, this week, we're going to look at what is the grazing area, or the amount of space and amount of grass that Pumpkin can eat within that circle. Okay, so an area of a sector is the concept that's going to be our focus today. Now, a sector is a portion of the area of the circle. Okay, so now let's go ahead and let's look at our problem for today. Bill's lawnmower is broken and he needs to cut the grass. Bill attaches his goat named Pumpkin to a 50-foot long rope and places it in 4 different areas of the backyard. Bill attaches the end of the rope to the following areas. The first area is going to be to a tree in the middle of the backyard. The second part is going to be on the midpoint of a 300-foot fence. The third part is going to be on the corner of the house, and the fourth part is going to be 30 feet away from the intersection of the 2 fences. So these intersection of 2 fences, we're going to place Pumpkin 30 feet from that intersection. Now the question is this: what is the area of the region that Bill's goat will graze in. We're going to round our answers here to the nearest hundredth. Now, the essential question today is how can we determine the sector area given the central angle measure? Now, key concept is area of sector. You're going to see a lot of similarities between this concept and the concept that we discussed last week with the bicycle sprocket as the chain moved around the sprockets of the bicycle. This week we're dealing with area. Now, with area of a sector, it is only represented of a portion of the circle, not the full circle. So, like last week, we're going to take the measure of the intercepted arc, which if you recall is also the measure of this central angle. We're going to divide that by 360, and we're going to multiply it by our formula for area, which is pi times radius squared. Okay, now, some materials that you will need for this lesson. You'll need a pencil, you'll need some paper, and you will need a calculator. We do have some computations that we have to do for this problem, and so a scientific calculator or a graphing calculator is needed. So we're going to go ahead and we're going to move on to part one, where pumpkin is placed in the middle of the backyard. Now, placed in the middle of the backyard, circling around a tree. Now, so this rope that's placed to pumpkin, it is 50 feet long. It's 50 feet long. He can graze in anywhere inside this circle. So we want to find the area for the region that pumpkin can graze in. So the area formula for a circle is A equals pi times radius squared. So here we have a radius of 50 feet. So pi times 50 squared. And 50 squared is 2,500. So we have 2,500 pi. Now, and that is going to be square feet. Now, it's important to note, last week when we dealt with circumference, it was in linear measurements, measurements that you could measure with a ruler or a tape measure. This week, when we're dealing with area, area is always going to be calculated in square units. Okay? Square units, for this case, would be square feet, would be how many square feet exist within this circle. And that's how we measure space. Two-dimensional space. So now this is 2,500 pi, rounded to the nearest hundredth. It is approximately 7,853.98 square feet. So if pumpkin was placed around the tree, this is the area that pumpkin can graze in. Now let's move to part two. Now Bill decides to move pumpkin to this fence. Now this fence is 300 feet long, and Bill has placed pumpkin on the midpoint of this fence, which that midpoint would mean that it's 150 feet on either side. Now we want to find the area of this region that pumpkin will graze in. So, if you recall, the area of a sector is m over 360 times pi r squared. Now the question that we have to ask is, what is the central angle measure here? So what is this angle measure here, which is equal to the intercepted arc? And it is 180 degrees. So now RM is 180 degrees over 360 times pi times the radius of 50 squared. 180 over 360 simplifies to the fraction of 1/2. So we have 1/2 times 2,500 pi. running out of space, so I'm going to put it over here on the right side. The area is 1/2 of 2,500. It's 1,250 pi. And when we punch that for part 2, it is 3,926.99 square feet. Okay, that is feet squared. Okay, so that is part 2. Now, part 3. Bill is going to now place the rope on the corner of the house. Okay, so we have the corner of the house here, and Bill has now placed the rope on the corner of the house. Now, the first question that we have to ask is, what is the central angle measure now? Now, since this angle is 90 degrees, 90 degrees is 1/4 of 360. That means that this angle is 3/4 of 360, which is 270 degrees. Okay, so our central angle measure, which is also our intercepted arc, our M is going to be 270 degrees. Okay, so we have our area of sector equals the number of degrees over 360 times pi r squared. So our number of degrees is 270 over 360 times pi times 50 squared. 270 over 360 simplifies to the fraction 3/4. So we have 3/4 times 2,500 pi. And 3/4 times 2,500 pi is 1,875 pi. And that is feet squared. Approximately 5,890. 0.49 square feet. Okay, so far we have found the area, the grazing area of Bill's goat in a full circle, in a semicircle, and in 3/4 of a circle. Now, this next part, which I really enjoy, because this is going to be a blast from our earlier in geometry past. We're going to have to pull on skills that we've already learned and we've already used and be able to apply it here. So let's talk about the context for part 4. Okay, part 4. Bill has moved the goat now 30 feet from the intersection of the two fences. Okay, so now what has been formed is a right triangle here. And then we have a sector that has been formed here. And we want to find the total grazing area for pumpkin. Okay, now, what I've done is this, is I've just clipped this down to where we can just hone in on the area that we're looking for. And remember this, it is formed by a triangle and then with a sector here. Okay, now, let's go ahead and find the triangular portion first, because once we do that, we can take the area of the triangle plus the area of the sector, and that'll give us the total grazing area for pumpkin. Okay, so if you recall, the area formula for a triangle is 1/2 base times height, or if we rewrite it, we can rewrite it as base times height divided by 2. So I'm going to write that in. Area formula for a triangle is 1/2 base times height, or rewritten and an equivalent expression is base times height divided by 2. Now, the height of a triangle is always perpendicular to its base. Perpendicular indicates that it forms a right angle. Now, so with this triangle here, if we use 30 as our base, then what is our height? Okay, and that's the question here. What is our height? Now, pulling from a skill that's previously learned, you can probably tell that this is a right triangle, and we have two sides of that right triangle. When we have a right triangle and we have two sides, and we're solving for the missing third side, we use Pythagorean Theorem. The equation for Pythagorean Theorem is a squared plus b squared equals c squared. Now, this happens to be a Pythagorean triple. Now, a Pythagorean triple are three whole numbers that satisfy the Pythagorean theorem. Now, here's the big thing that's a good nugget for us for the Pythagorean triples, is that the ACT loves them. Okay? This is a great ACT strategy that will save us time on ACT problems if we know three main triples for the ACT: a 3, 4, 5, a 5, 12, 13, and an 8, 15, 17, or multiples of those three. So I want you to notice this. This isn't a 3, 4, 5 Pythagorean triple, but it's a 30, 40, 50. Okay, so 30, 40, 50 Pythagorean triple. That means the two legs are 30 and 40. That's the base and the height with a hypotenuse of 50. So if we're going to calculate the area for a triangle, we're going to take 30 times 40, and we're going to divide that by 2. Okay, now, so we have 30 times 40, okay, which is 1,200, divided by 2, and that is 600 square feet. Okay, so we have this part here, and that is going to be 600 square feet. Now we have to find the area of the sector. Now, for this sector, there's one thing that we need. We know that's M. This central angle is equal to that. Now, we've got to figure out what that central angle is. Now, in order to do that, we're going to pull on another skill that we've learned previously, and that is right triangle trig. When you have a right triangle and you're looking for a missing angle, okay, we are going to use the inverse, either sine, cosine, or tangent. Now, if you recall our trig function, SOHCAHTOA, sine is the opposite side over hypotenuse, cosine is the adjacent side over hypotenuse, and tangent is the opposite side over adjacent. So, if we look at what we're given here, 30 and 50, 30 is adjacent to x and 50 is the hypotenuse. So we're going to use the inverse cosine. So our equation will be cosine x equals adjacent side, which is 30, over 50. Now we're going to take the inverse cosine of both sides. Okay, taking the inverse cosine of the left side isolates. Okay, isolates that variable. So now we have x equals the inverse cosine of 30 over 50. Now, when you do that, you get approximately 53.13 degrees. Okay, so x is approximately 53.13 degrees. Now, as a result of that, what is the measure of M, which is the central angle measure right here? What is the measure of M? All right, now, we notice that these are a linear pair, which means they form a line, two adjacent angles that form a line. So we have this. M is going to be approximately 180 minus 53.13. Okay, 180 minus 53.13, that is 126.87. Now, that angle is our M. So for our area of sector, we're going to have 126.87 over 360 times pi times 50 squared. Okay, so we're going to punch that in our calculator. 126 divided by 126.87 divided by 360 times pi times 50 squared. Now, as a result, the area of the sector is approximately 2,767.87 square feet. So we have, okay, our area of triangle is 600 square feet plus 2,767.87 square feet which is going to be, our final answer for this part is going to be approximately 3,367.87 square feet. Okay, now, so we've answered all 4 parts. Now, I want us to look at an extension to this. So, what if this was asked, what is the remaining area that pumpkin has not grazed in yet? How would we approach that? Okay, so here's how we would approach this. This is an extension question that you can do on your own. Okay, I'll give you the answer in just a moment so you can practice this at home. But you would take the area of the backyard, which is going to be a composite figure, okay, made up of 2 rectangles. So you find the area of rectangle 1 plus the area of rectangle 2. That would be the area of the backyard. And then you would subtract all the areas that we already found. So you would subtract the sum of the areas from part 1 through part 4. And you can try that on your own. If you do that, okay, the final answer for that will be 6,956.67 square feet. Okay, again, this will be approximately 6,956.67 square feet, and this is a problem you can do on your own, and you can check your work with that answer. Now, that concludes the lesson today, but I want to go ahead and talk about something that we're going to discuss next week. Next week, we're going to transition to volume. Volume is the amount of space that fills up a 3-dimensional solid. Okay, now, next week, I want you to look at this. We're going to take a bucket and some concrete with a steel bar, and we're going to see what we're going to do with that and what we're going to calculate with that. So I look forward to seeing you next week. Have a great day.